Swayam Prabha. Digital India. Educated India.
Welcome back. In this lecture, we will talk about land use transportation interaction. The topics covered in this particular lecture would be land use transportation interaction and its purpose, other linked phenomena and systems, and then land use transportation feedback cycle. So these are the three concepts that we will understand in this particular lecture. While we have already studied land use and we have also studied transportation and also to some extent the land use transport interaction, we can say that land use transport interaction is not simple and is connected through and land use and transport is connected through travel behavior of individuals, which is again linked with several urban phenomena and systems. That means we have land use, we have transportation, and we have travel behavior in between. And this travel behavior is again influencing many other urban phenomena and urban systems. So, for example, if you look at the slide, the first box that you see on the screen is macroeconomic development, which includes GDP, change in GDP, change in employment rate, change in job creation, which is also part of the urban system, which is an urban system in the sense the change in macroeconomic environment leads to change in the number of jobs, leads to change in the number of people employed, and also that growth of, in general growth or prosperity of that particular urban region. So macroeconomic development is important for urban areas, and with increase in macroeconomic development and with increase in creation of jobs, you see people migrating from rural and urban, rural to different urban areas, or from urban to another urban area where growth is taking place. That kind of migration also happens. And then we have directly also this macroeconomic development also influences population growth, decline, and household formation in a particular urban area. So when people are more prosperous, then they will decide on certain events which also changes their life. For example, they may go for a new family, they may create their own family, they may move out from their existing houses, and they may from their parents' houses, and they can buy their own houses. So different events takes place when the economy is good, or there is prosperity, or there are jobs. So this kind of changes comes along, and when this population growth and decline or household formation happens, it will lead to change in the demography in a particular urban area, particularly the change in the total number of people as well as the distribution of people in the different zones in that urban area. For example, when population growth happens or household formation takes place, people will buy a house or they may rent a house. So that means that results in a requirement or a demand for urban buildings or buildings in urban areas. So when buildings in urban areas is demanded, then it has to be supplied. So real estate developers come forward and then they will start building new buildings in an urban area, and that actually requires the land use planners to also provide land. So that means the land use growth or provision of certain kinds of land use in an urban area is linked with building supply or the amount of building that would be constructed by the real estate developers, and then who would be using these buildings or who would be coming to these particular buildings to stay. So this entire process is linked. So you can see when there is macroeconomic development, that means there is job creation. We also require new offices to be come up. So again, real estate developers will come and supply commercial office places, and that will lead to change in the land use. So both population, jobs, these are all changing the land use, and the land use on the other hand can change, or because of the provision of new office buildings in certain wards or provision of new housing in certain parts of the city, you will see the demographic pattern and the demographic structure of a particular area changes. So that will lead to demographic change. So this is, you can say that, okay, while this is a forward change, this change is happening in this direction, so there is a reverse effect as well, which is coming from the land use side. So then again, when demographic patterns and distributions are changed in an urban area, that also leads to change in the transportation system. So that means the mode choices, the travel distances, the travel times, all these things will change, and that will also change the land use choices, the accessibility of the land use, and so on. So this is how the different systems are linked, and eventually there is also change in technology and infrastructure. And when you change technology and infrastructure, that is change in the basic structure of the transportation network or the transportation system, and also change in the land use or certain kinds of building use. Those could come because of this new technology changes, like green buildings are being taken up. So all these things will come up for that. So that basically means the different systems are linked, and the linkages are not one way, they are in both ways. And these systems are not it's not a straightforward linkages. There are feedbacks coming from each and every one to the other system. So this has to be ascertained. So what can we achieve through integrating land use and transportation? That means when we are doing a land use transportation model, why shouldn't we just try to determine what is the traffic flows in a particular street and then get done with that? So, but we need to do also change. We need to determine the change in the land use pattern, change in the building use pattern, change in all the connected system. Why it is required? It is required because if we do that, then only we can say what would be the effect of change in population and population characteristics to these particular systems that are connected. We can also say what is the effect of addition of a highway or a ring road or a flyover or even a sewerage network in a particular urban area. For example, when we add a sewerage network, it will increase the capacity to increase the certain characteristics of that particular area. How? It may increase the carrying capacity of that area. So that means more number of people can actually come to that place and leave. So that means it is going to change the attractiveness or accessibility of that particular area, and that will lead to change in the transportation system as well. So you can see effect of infrastructure addition is again not straightforward. It is not directly affecting land use, it is not directly affecting the transportation system, but it is affecting by changing the accessibility of that particular area. So similarly, land use and building use restrictions and change. For example, by restriction I mean FAR restriction or density restrictions. So that means in a particular area, if I restrict the FAR to a certain value, then you will see there is a certain effect. So, or when we are trying to achieve compact development or transit-oriented development of certain zones in the city, we can increase the FAR of those particular areas, and we will see a resulting cascading change in both the land use, transportation, and many other systems, which will also affect each other. So then effects of policies like parking availability or pricing. So this is in central areas, if you increase the price of parking, then automatically people will be choosing transit system. Now, if to some extent, and then if they choose transit system, then probably the demand for new buses will increase, and that will also increase the requirement for parking them in the terminal, and so we have to provide a new terminal facility for them. So that actually is a feedback back to the land use. So these are the changes that we will be able to predict, and then introduction of new modes of public transit services, effect of toll and pricing policies on certain roads, then economic climate and other cost effect, like we can also determine, okay, what kind of change in land price will happen in a particular locality, and that will actually determine if people are going to buy buildings in that particular locality or that particular TAZ. So these are the things that we can measure when we have an integrated land use transportation model, and we can also understand what is the effect of small, compact development, mixed use development using this sort of models. How do we predict the impact of integrated land use transportation policies? So we can when we are talking about a model, we have already discussed a 4-stage model that is being required in the comprehensive development plan. But as such, there are certain decisions when we have to decide if we require a model or not. Not all decisions require a model. So we need to also understand which are the things for which we have to develop a model, which are the things we cannot develop a model, or rather developing a model is too difficult because we don't know all the variables that should be required to develop that particular model. So that being said, I can say when we want to understand the impact, or rather predict the impact of integrated land use transportation planning, then there are different ways we can do that. We can either observe the behavior of different kinds of people under different circumstances, and then we can decide what is happening. For example, I survey a group of people and find that, okay, some of them are choosing, 50% of them are choosing public transit, whereas 25% of them are choosing personal car, and the rest are choosing other modes. So I can apply this survey result to another corridor of the city which is more or less similar. But it may be right, it may be wrong. So there is no, we cannot say that this will give me the exact result, but it's most likely there would be certain changes from one corridor to another corridor. So it is difficult to predict, but for certain cases where the situation is more or less simple, we can just depend on that. But as soon as I ask, what will happen if I introduce a certain mode along this corridor which was not there? In that case, this particular way of doing this survey would probably not be able to answer that. So instead, I would have to ask people, will you choose a particular, will you change the mode from car to bus if parking cost is increased, or if a new mode is being provided? So this kind of questions we can ask. So that means we can also ask people about the decision. So as you can see, the first part, that is when we can observe the behavior of different kinds of people and then comment on what is the choice, that is, we can also refer to that as revealed preference to some extent. And whereas we ask people that, okay, what is, what they will do when certain thing is which is not there now but has to be provided or will be happening in future, then that is called stated preference. But as you can understand, whatever people state, that is based on their perception at that point of time, but eventually when the time comes to take a decision, it may be significantly different than what he is actually stating now. So this kind of discrepancies will remain, but at the same time we can base our decision based on these broad feedbacks that we get from the people. But as you can understand, it's very difficult to implement these feedbacks in other situations. Even feedback for one corridor cannot be used to explain the final outcome in another corridor, and for that matters, we also are not able to determine what is the impact of a particular change on a particular policy on the choice that a person makes. That also we cannot comment on. So to do that, we need to develop mathematical models. So we can simulate human decision behavior using mathematical models, and that is why we need to develop this 4-stage travel demand model, or a modeling system for urban land use and transport integration. That means instead of just asking people what is their wish, or trying to find out what they have chosen, we are trying to develop a simulation system or a new way to determine how we can predict in a different situation using the data that we have collected from existing situations. And as long the situations are more or less similar, we can use the same models, we can apply that. For example, if we are doing survey on 2 bus corridors and asking them, okay, what is their perception, what is their mode choice between bus and personal car or taxi, then we can use these findings and we can use this particular model that we develop in another corridor in an urban area, which would probably not have been possible if we have depended based on the broad feedback that we get from people by doing the surveys. So, summarizing this, we can say mathematical models can predict human behavior in unknown situations and context, as long as the situations are similar to the condition based on which it was developed. So that also means if I develop a model for a city in India, probably that model is not going to be applied or directly applied in a city in America or any other developed country. So what matters, but the fundamental components of the model, or rather the variables or the characteristics that we will use to do the model, may remain same, or maybe certain more variables should be added, but the model needs to be calibrated separately for that other place or that other situation. So that is why we cannot use the same model, but we can use a variation of the model by calibrating it for many situations, and that will save time on survey, and we can reduce on survey cost in those particular areas. So mathematical models are also the only way which affects where we can determine the effects of different attributes or factors while keeping the other factors fixed. So that means when we have a choice model saying that the cost, the time, and then the comfort level of a particular mode influences my mode choice, I can say, keeping everything fixed, how if I increase cost, what effect it will have on the choice of that particular mode in that particular corridor. So that means we can also understand which of these factors could be changed to improve a particular, or rather to change a particular outcome in a particular mode choice outcome in a particular corridor. So that becomes that we can adopt that particular policy in future. So that is why a mathematical model is always useful in trying to determine policies which will help us to decide on future changes for an urban area and to also evaluate the outcome of that policy. So there are several linked phenomena and system that is considered while we study land use and transport interaction that we already discussed. But some of this phenomena can be categorized into 4 types. The first one is very slow changing systems or phenomena, then slow changing systems and phenomena, then fast changing systems and phenomena, and very fast changing systems and phenomena. So what are these very slow changing systems? We can say the urban networks or the urban land use are very slow changing systems. We don't see changes in the land use overnight. We may see that changes happen over a period of time, and probably the period is something like at the end of 5 years, we can see there is significant change that could be ascertained, or we can determine that there has some amount of change that happened after the end of 5-year period. Or if I take a 20-year period, then we will see quite a bit of change. So it depends also on the time that we are considering or the time frame that we are considering. So similarly for network, if a road is present today, we won't tomorrow the road is most likely it is also going to remain tomorrow as well. Same with utilities and communication network. So this kind of systems don't change, but what happen is there are incremental changes. That means the road may be widened within a period of 5 years, or within the next 5-year period the road may get extended by another kilometer. So this can happen. So there are incremental changes. Same with land use. That means the land use percentage changes from residential 25% to 27% maybe at the end of 5-year period. So this kind of incremental changes happen, and these are very, very slow. So we need to understand in the modeling process, or when we are talking about interaction between different systems, which systems changes very fast, which system changes very, very slowly. So similarly, when the changes are very slow for a planning period, we can take that input as exogenous. What it means is, that means during a 30-year period, we can expect that a total number of new industries that come to an area, we can have that figure for that. But we can say, we can take it as an exogenous input, because it is very difficult to model how many number of industries will come within a 30-year period in an urban area. But the planners can set up a target that within an urban area, within a planning period of 30 years, so many industries has to be brought in. So this could be taken as an exogenous input in the modeling process of land use transport interaction. So For example, development plan, master plan for planning area guides development within the planning boundary. So whatever are the suggestions given in the development plan, that can be taken as exogenous input which we can consider for a particular urban area, and we can say that if those changes are considered as input, then what are the changes in the other system. So that is how we can model this very slow changing phenomena and systems. And similarly, areas beyond planning boundaries usually experience organic development and are eventually included in the planning area when it is extended. So what it means is, for very certain areas which are like in the master plans, we know that certain areas have been planned and we can take them as exogenous inputs from the master plans, whereas certain areas which are not within the planning area, which is outside the planning area, like peri-urban area, or it's a gram panchayat area, which is most probability a village and in a rural setting. In that area, changes gradually happen, and eventually certain amount of urban, we can say that that area has got urban characteristics, and we eventually bring it into the urban area, or we adopt that, or we include that area in our urban planning boundary. So there we need to predict what changes has happened. So we may not be able to getting that data from master plans. So there, to determine my transportation system now, what changes are going to happen in those peri-urban area, I need to predict what is going to happen in the peri-urban area, and for that we can use remote sensing and GIS, this kind of maps, and then what we can do, we can determine land change models. These are a group of models, LCM, which in short we call them LCM. This sort of models could be used to predict the organic development in the surrounding areas. Then slow changing phenomena and systems. We can say while land use and networks are very slow, buildings, including all sorts of buildings, commercial, institutions, offices and housing, these are slow change. These are not very slow, but these are slow changing phenomena and system. Why slow? Because a building, the age of a building or the time a building lasts from 50 to 100 years. So within that 50 to 100 years, you will see a particular residential building we may see multiple occupants. That means a building may change hands, somebody new, a new family may buy that building, or it could be a rented building. We can see different sorts of families coming to rent that particular building. Or if it's an office building, similarly we can see that new offices or new farms will take up the building on rent. So this, while occupants change, the building remains for a long time. So that also we can understand. That means buildings are not added during very short time planning period plans where the planning period horizon is very small. We may consider building as an exogenous input. We may not consider modeling or the process for determining how many new buildings are going to be built in an urban area. So that means we can take them as an exogenous input from development plans, and accordingly we can develop our land use transportation interaction modeling system. So usually in an urban area, new building construction happens when buildings are either demolished or they are transformed. For example, we have a G+2-story building. Now the owner wants to make a G+4-story apartment building. So there is transformation happening, even though the building is not that old, or the building may be old, and it may face obsolescence, and then it needs to be demolished. So that is when new buildings will be constructed. So we can go with very broad estimates of how many buildings are being constructed, how many buildings are being demolished, and we can take also feedback from the development plan and say that, okay, these are the new areas where new buildings needs to be constructed. That is what we can determine. And we can say that, okay, these are the buildings which are slow changing, and this phenomena is changing slowly and not that fast, and we can take that as an exogenous input. And similar to buildings, we also have land price. That means whenever our new buildings are being constructed, we can also we can see that there is some, because of demand and supply, there is change in the land price, and that land price, even though the building is slowly changing, the land price is actually not slowly changing. The more supply is added to the market, the land price may fall. If the demand is more, supply is less, then the land price may rise, at a much more faster pace. So land price may not be slowly changing, even though the the change in the number of buildings may be very slow. So either we can take this as an exogenous input from master plan and development plans, or based on housing deficits that we estimate for a particular urban area, and we can also consider if the time planning period is pretty large. For example, we take a 20-year planning period, we can also determine, or we can develop models for supply and demand for new buildings, and we can also consider it as an endogenous input to the land use transportation modeling system. So what it means, we will have one component which also models new building construction in an urban area. So next comes the first changing phenomena and system. So when we have buildings doesn't change overnight, but the number of jobs that are there in a particular area or a TAZ, that can change fast. So new jobs are created and lost, and when new jobs are created, it creates both, there are these direct employments, also creates some indirect employments. So these jobs, and then the population, new jobs, when they are added, it changes the employment distribution of a particular area. Similarly, when new population is added or new households come into place, then population distribution of an area changes. So these changes are relatively faster compared to buildings or land use. So these are fast changing phenomena, and these are in most likelihood modeled in an urban land use transportation modeling system. So when we consider population, we consider the natural growth of the population in that urban area. We consider in-migration and out-migration of population to that urban area, which again could be an exogenous input. Then we have demographic changes that takes place in an urban area, and a household changes that takes place in every TAZ in an urban area. This could be modeled using the models that we develop. And when we have a population distribution model or a population location model, we can also develop a car ownership model. That means which population group or which kind of households can also own car, and this also changes at certain intervals. The number of the frequency in which a person chooses a job, or a frequency or changes a job, or buy a car, can be called as fast changing relative to the construction of buildings or change in land use in an urban area. So when we look at the household transition process in an urban area, so we need to, these models actually need to determine how many households are created and how the households grows and eventually dissolves. That means when a new family is formed, but eventually at the end of a certain period, certain families also dissolves. That means single family housing, single family household is there, then the person marries, has got a family, it becomes a two-member family, and then when this family has got a child, then it becomes a three-member family, and when the child leaves the home, it becomes again a two-member family. When somebody dies, it eventually becomes a one-member family, and then eventually it dissolves. So this transition process needs to be checked, needs to be traced, and then based on the different stages of their life, households also change the location of their stay, they change their employment, they change their vehicle requirements. This also needs to be predicted for an urban area. So all this depends on the planning horizon and the planning boundaries that we adopt. So based on this, we need to decide should we include them in our modeling process or not. But there are certain phenomena which changes very fast, and some of that changes every day. For example, certain habits, certain subscription, certain constraints, certain obligations changes due to fluctuation in demand or due to certain amount of excess of those particular habits or those particular subscriptions and so on. What it means is that, for example, the fare changes for a particular transit system, then people may change the mode. So that's a very short-term change. Or person has bought a transit pass for a particular corridor, so he is most likely to use the transit pass for a period which is may not be very long, but for the period when till the pass is valid. So for that period he is going to use transit, and that is fixed. So these are the decisions. And similarly, there are perceptions, like for example, a person's perception about a city's transit system or a neighborhood. It doesn't changes overnight. It takes some time, but still it could be changed by provision of a new infrastructure or provision of a new service, which is relatively faster. And then there are certain things, so we can call them as short-term changes, and then there are certain things which changes dynamically. For example, time, congestion pricing, parking availability, transit crowding. These are all dynamic phenomena which could be also influencing land use transportation choices. For example, a bus is crowded. That will, if the bus is crowded during a particular hour, a person will avoid bus usage during that particular hour, but he may use it during other hours. So that's a dynamic change. Or he may see a bus coming which is filled to the brim, so he will not get on that particular bus. Or same goes as parking availability. If a person is checking the availability of parking in a mobile application, or there is an information system in place, he may see parking is filled, so he may not take his vehicle on that particular day. So these are very, very dynamic changes. Or similarly, if there is congestion along a road and you are using open source data like Google Traffic, you can immediately decide to change the route or even your mode. So these are dynamic changes that can happen, and that should be able to be captured by a land use transportation model. And finally, when we consider urban environment, there are certain effects which are immediate, like noise and air pollution. That means in an urban corridor, if there is a lot of traffic, it will lead to more noise, more air pollution. There are certain long-term impacts like water and soil contamination, which also happens from different kinds of land use choices that the city has, or land use structure the city has got. So these choices also needs to be modeled, or rather this kind of changes needs to be modeled in the land use transportation system. And as a feedback, the environment also impacts location choices. If an area's environment is not that good, people will not choose to locate to that area either for job or for residences. So to bring the entire land use transportation interaction process into a comprehensive list of systems, phenomena, and actions. This particular image, this is a very famous image which is called the land use transport feedback cycle, and this was developed by Michael Wegner. And you can see in this particular image that there are several. We have land use and transport, and as you can see, a particular instance of land use and transport leads to certain activities that a person does in a particular day. Activities means he goes to school, he goes to work, he goes to a restaurant, or he stays back at his residence. That his presence or his setting of land use and transportation helps him to decide on should he own a car or not. So he decides to buy a car. He may not decide to buy a car, and once he has got a car, then during his trip decision and his destination choice, which could be in sequence or it could be together, he can decide on which either to take the car or to choose public transit, and that becomes the mode choice. And then once the mode choice is done, then he can also look into the route choice. That means which route he will take, and that he will choose the different links which will change the travel time along those particular link, and it may, depending on his choice of a particular route, his cost may also be different. And when the cost is different, that will influence his mode choice, because in certain routes the mode choice, certain modes are available which are and each mode choice comes with a certain price to it. And similarly, if he chooses a particular route, it may also change his trip decision. He may feel that, well, today it seems like the entire network is congested, I will not travel today, I will travel tomorrow. Or even I can change my destination. I was feeling to go for a movie at a particular area, I may feel that, well, I should change my choice to a nearby area. So all these effects in short term changes all these choices, Whereas in the long term, it changes accessibility, which is a fundamental characteristics which is related with land use. So that means when accessibility changes, the land attractiveness of that particular land use changes, which is over here, and that will allow people to, or the location decisions of different investors and people to decide on different things. For example, a real estate developer would decide to construct in an area which is very, very accessible, or a person would like to locate his residence or like to buy a house in an area where he will which area is accessible as well as and obviously attractive. So that will lead to his movement from his existing area, and when he moves from his existing area, he again will land up in a new area which has got its own land use and transport system, which starts that chain of activity which we already described. So this is the land use transport feedback cycle, and this also summarizes the relationship and the linkages between the different urban phenomena and systems. And as also discussed earlier, we can say while some of this phenomena is driven by market forces, some of this phenomena is guided by urban rules, regulations, policies and existing plans like development plans which are already in place. For example, a master plan has indicated that certain areas are reserved for residential land use, so your choices could be only between those areas. So that is how an existing plan is actually deciding on what would be your available choices for a particular activity or a particular location choice and so on. So accordingly, we can develop, when we develop our mathematical models, we can consider certain systems as exogenous to our mathematical models. That means we will not model them. We will say that these would be taken as inputs from existing plans and other documents, whereas certain systems are endogenous. That means we will develop the models for those particular systems, and we will see how these models or these particular systems will influence each other, and that is what a land use transportation interaction is all about. So this is the reference book that you can follow, Handbook of Regional Science, and there will be other references we will add on when we do different components of this land use transportation interaction models. So we will give those references later. And to conclude this particular lecture, we can say land use and transportation linked to several urban phenomena and systems, which not only influences the various decisions taken by individuals in regards to the travel behavior and land use choices, but also each other. That means it doesn't only changes land use and transportation, but also changes each other. So all these urban phenomena, for example, location choice for housing and development choice of housing by real estate developer, these are linked. Time is an important dimension in urban planning, since decisions taken by individuals are also bounded by time. And mathematical models of urban phenomena and systems, including land use and transportation, should consider the linkages and feedback between themselves to arrive at appropriate results. Thank you.